We began with each sample taking 1 full cup of cement and adding to it the correct amount of water to reach our water-cement ratio for that sample. Once we had combined both the water and the cement in a mixing bowl, we stirred them together using a wooden stick to ensure that the entire mixture became fully hydrated. To ensure that the cement was properly filled all the way into the cup without having any air bubbles, we vibrated against the ground and also used our hands to kind of tap it in and bring all the water to the surface of the sample. We then took the temperature of each of the samples as it was curing.
We began curing our concrete at 6:30 p.m. Tuesday evening and ended 36 hours later. Half of our samples were immersion cured and half were evaporation barrier cured. All but 2 samples were at an ambient temperature of 82 degrees, while the other 2 were at an ambient temperature of 40 degrees in the fridge.
For our testing, we have devised a method of putting our concrete sample in between 2 car jacks. We did this to ensure that our concrete samples would go from full strength to complete failure in one try. This was to eliminate errors such as having to do multiple tests and weakening the sample and not getting an accurate reading. So what we're doing is we have a jack on one side and a jack on another, and the concrete sample in the middle. And what we're going to do is we're going to calculate the strength based on percentile by how many turns we have of each crank. And we'll start at 0, and then when the concrete sample comes to failure, then that's how we'll record it, and we'll compare those averages to get a percentile.
Sources of error in our project include primitive mixing tools, the inability to perfectly line up the jacks horizontally, and inability to have the exact same starting pressure before each failure test.